Well, this is a great opportunity for me because it's a practice, live practice for me in English. So thank you, Fabiana, for helping me to do this today. So, well, we are going to talk about 3D printing. Thank you for joining in this session. My name is Antonella Lagazzi, and today I will be presenting some technical concepts about 3D printing, also called additive manufacturing. The goal is to give you a clear and practical overview of the most important concepts, technologies, materials, and applications. So you can better understand this rapidly growing field, yeah, an interesting field. Um, so, what is about me? I am a materials engineer with a professional experience in additive manufacturing, mainly with polymers. Over the past few years, I have worked in both in research and industrial settings, supporting product development, quality control, and customer training. I'm passionate about technology, and right now I'm also expanding my skills in data science. One of the things that I enjoy most is sharing the fundamentals of 3D printing with new audiences like today. So, what is 3D printing? Maybe you have heard this term before. So 3D printing is a group of processes that build parts layer by layer from a digital 3D file. That's why we also call it additive manufacturing because we add material instead of removing it, which is what we do in traditional subtractive methods like machining. The typical workflow is this graphic is first we design the part in a CAD computer aid designed software or program. Then we use a slicing software that divides the 3D model into layers and generates the instruction for the printers. The machine prints the part layer by layer. And finally, we perform post processing like cleaning, curing, or finishes. It depends. So we have some technologies like uh, FFF or FDM for polymers, for example. This is the most common and accessible polymer process. A plastic filament is melted and extruded through a nozzle, depositing layers that fuse together. We can use materials like PLA, ASBA, PETG, nylon, and flexible TPU. Some numbers, names of materials, specifically polymers. The main advantage is low cost and easy use. This is, like I said, the most common accessible polymer process. The downside is that layers are visible. The parts can be weaker between layers. That is a term known as anisotropy. And we need support for overhangs. This is a huge problem hit you problems in this technology. Then we have SLA or DLP that is also for polymers. Here, instead of a filament, we have a vat of liquid resin. This is the mainly difference with the past technology. The resin is cured using a light. This light is a laser in the technology named SLA or a projector, a digital light projector in DLP. This technology creates a very high resolution parts with a smooth surface. This is a quality of this technology. The drawbacks are that resins can be brittle, and then we maybe need post processing, washing the parts printed, and then curing them with UV light to achieve the final properties. So we have some steps to achieve the proper part printed. And then we have a technology, an interesting technology that it's called SLS and MGF, also in polymers. These are powder bed polymer processes. So we have another state of matter that is powder. In SLS, a laser fuses layers of nylon powder. We have a specific material here that is nylon or polyamide. And in MGF, a fusing agent is deposited and then fused by infrared energy. Because the surrounding powders supports the part, we don't need support structures, and this is really, really good for a term or a surface, a smooth surface. The parts are strong and can have very complex shapes. So we have like uh, angles, small angles, or difficult shapes. So the surface can be slightly rough or grainy because we build these parts from powder. Then an interesting technology, and we mainly not think about 3D printing in metals. So now we have a lot of technologies like this, like PDF or EDM, and that are a laser in the case of PBF or an electron beam in the case of EBM that melts thin layers of metal powder, building very strong and complex parts. So the materials used in this technology are, for example, titanium, stainless steel, aluminum, inconel, and many others alloys. So it's really, really interesting, and the application for this technology will be aerospace, for example, that use alloys very strange or particular for the parts. And this is a high performance process used in aerospace, like I said, in medical industry, but it is expensive and requires post processing like heat treatments to relieve stresses, internal stresses. This is a mechanical concept. Another technology, very, very interesting nowadays, is DED and binder jetting. DED is directed energy deposition that fits powder or wire. So we have this alternative into a melt pool created by a laser or arc. It's like a soldering. Uh, it's a deal for repairing or adding material to large parts. So it's a combining technology. Binder jetting instead is faster and brings a binder onto a powder bed. After printing, the part is very fragile, called the green part. This is a very common term in this industry and must be sintered in a furnace to gain strength. These methods are great for speed and repairs, but dimensional changes during sintering can be a challenge because we have a contraction, a high contraction of the part. We have here a diagram of this process, and this binder jetting can be used uh, with metals, but also with polymers, like a printer, a paper printer, for example. And very interesting too, we have 3D printing with ceramics, and here we have a image for a 3D printer in ceramics, but for decoration, for example. But we can use this material for another application like dental devices, electronics, and high temperature components. This is the additive manufacturing, less common, but right now is growing quickly. Uh, we can use photopolymerization, for example, that is a process in polymer that involves light with ceramic suspensions, that is mainly liquid with some particles of ceramic, specific ceramic. And we can use the process that we talked before, binder jetting, with ceramics too. And some materials in mm, this group of ceramics, we can hear about alumina, zirconia, and silicon carbide. So I talked a lot about these processes, and I think that we have a lot to know about them. But I copy three or four terms that we usually heard in this field, in 3D printing or additive manufacturing, that it's similar talk about these terms. So we have STL, that is the most common 3D printing file format. We can exchange or share this file format. It's something like a mesh of points in the space that build the part, and it's the configuration or the form that the software to design the part understand the form, the geometry of the part, for then make something with another software and then print the part. The term slicing. Slicing is dividing the model into layers and generating machine instructions. So we have nowadays some softwares from different companies that makes this process, and you can preview the part before you print in a 3D printing, no matter what process you will use. So you can prevent some failures of the print if you visualize correctly in these softwares that makes you slice the part before print. Then we have a layer height, that is the thickness of each layer. That is very important because this term of this parameter affects resolution. That is another characteristic of a 3D printed part. If you have a height layer height, you could see the layers in the final part, and maybe you are talking about low resolution. And the contrary, if you have a small layer height, the thickness of this layer is very small, you have a high resolution and you barely see the lines of the layers one another. Then we have the infill. The infill is the internal lattice of the or the percentage of filling. So in 3D printing, obvious depends of the technology, but generally we have an infill or filling in the part, and we can control the percentage of that filling and the geometry of the filling. So it's really important because with this parameter, we can control mostly the mechanical behavior of the part, or the final part, the 3D printed final parts. It's really, really important. And the majority of the time you have to make several tests to discover the best configuration of layer height, infill, and other parameters that are really important to achieve a correct and mechanical, and maybe with the material selection, chemical behavior of your 3D printed part. So I want to recap some ideas uh, of this topic, that is 3D printing. So, additive manufacturing builds parts layer by layer from digital data. So, we have a software that it's a CAD software, and we build the part, and then we manufacture that part layer by layer. Depends of the process that you use for build that part. Yes, we have some different parameters, but generally is layer by layer. There are many processes and materials, each with pros and cons. You have to, like an expert in 3D printing and or additive manufacturing, you have to select the better fit with a process and material and configuration to achieve the better behavior and properties possible with your part. And knowing the terminology like STL, slicing, supports, and sintering helps a lot where you are interpreting the process, the part, and the requirements of this process. And finally, 3D printing is already impacting many industries. So we have a lot of applications that we can use the 3D printing. Like I said, aerospace, medical, industrial, educational. So it's a lot of application that we call talking and in another um, moment with you. So thank you for listening to me. And if you have questions for me, I'm really happy to answer and talk a little bit more of this topic.